Most people think robots are simply machines programmed to repeat basic physical tasks, but in reality, robotics is entering a completely new era. Artificial intelligence is now moving beyond software and becoming physical infrastructure through autonomous machines capable of interacting with the real world. This is what many now call the robot age. At its core, this trend is about autonomous physical intelligence. Robots that can perceive environments, understand spatial information, make decisions, and execute tasks with minimal human intervention. And this transformation is beginning to reshape manufacturing, logistics, healthcare, defense, and global supply chains. To understand why this trend matters, you first need to understand the economic forces driving it. One major driver is labor scarcity. Many countries are facing aging populations and shrinking workforces, creating enormous pressure to automate repetitive and physically demanding tasks. Another driver is the rapid breakthrough in spatial AI and computer vision systems. Robots are becoming capable of understanding 3D environments, recognizing objects, and reacting dynamically to changing conditions. Hardware costs are also falling rapidly. Sensors, actuators, processors, and robotic components are becoming cheaper and more scalable every year. At the same time, companies are trying to build more resilient supply chains that rely less on fragile labor networks and global logistics disruptions. And behind all of this is the global productivity imperative, the growing need for 24/7 operational systems capable of supporting modern e-commerce and industrial production at massive scale. Today, robotic infrastructure is increasingly becoming the physical manifestation of artificial intelligence. To understand how this ecosystem works, you need to break it into 5 major pillars. The first pillar is industrial and warehouse automation. Autonomous mobile robots, robotic sorting systems, and automated forklifts now operate inside large fulfillment centers and manufacturing facilities around the world. The second pillar is humanoids and service assistants. These are multi-purpose robots designed to assist with elder care, hospitality, healthcare, and physically demanding labor environments. The third pillar is precision medical robotics. Robotic-assisted surgery and automated laboratory systems are providing levels of precision and consistency that human hands alone cannot achieve. The fourth pillar is autonomous delivery and drones. Delivery robots and aerial systems are creating new logistics models capable of bypassing traffic congestion and accelerating fulfillment. And the fifth pillar is spatial AI and machine vision, the intelligence layer that allows robots to see, map, navigate, and interact with the physical world. Behind the scenes, operating robotic infrastructure requires highly advanced coordination systems. Companies manage large fleets of autonomous mobile robots in crowded industrial environments, optimize path planning algorithms to avoid collisions, monitor sensor telemetry to predict hardware failures, and coordinate collaboration between humans and robotic systems. At the center of this ecosystem is a highly structured value chain. It begins with sensor fusion, collecting visual, spatial, and environmental data from the real world. Then comes spatial AI processing, where software models interpret the environment and make decisions. Next is actuation and control, where robotic systems physically execute movements and tasks. After that comes fleet management, coordinating thousands of robotic units across facilities and logistics systems. And finally, the end-user service layer, where robotics delivers measurable productivity gains to businesses and consumers. Now, who is actually buying this technology? Retail and logistics giants are investing heavily in automated fulfillment infrastructure to support global e-commerce growth. Healthcare systems are deploying robotic surgery and automated pharmacy systems to improve patient outcomes and operational efficiency. And industrial manufacturers, defense organizations, and strategic infrastructure operators are increasingly using robotics for hazardous environments and mission-critical logistics. Now let's talk about monetization. One major revenue source is direct hardware sales. selling robotic systems, machine vision sensors, and industrial automation equipment. Another fast-growing model is robotics as a service, or RaaS, where companies generate recurring subscription revenue from robotic fleet deployment and maintenance. Software licensing is also becoming increasingly important. Many robotics companies monetize proprietary operating systems, computer vision platforms, and AI coordination software. And long-term maintenance contracts generate stable recurring revenue through repairs, calibration, upgrades, and over-the-air software updates. Several major companies are emerging as structural leaders in this ecosystem. ABB dominates industrial robotics and factory automation infrastructure. Teradyne is a major player in collaborative robots and automated testing systems. Zebra Technologies provides tracking and machine vision infrastructure for warehouses and logistics. In healthcare robotics, Intuitive Surgical remains the global leader in robotic-assisted surgery systems. Tesla is attempting to leverage automotive AI capabilities to mass-produce general-purpose humanoid robots through its Optimus platform. And companies like Cognex and Keyence provide the high-precision sensors and machine vision systems required for robotic perception. Now let's talk about where this trend is heading next. Generative AI is beginning to allow robots to understand natural language instructions and operate with much greater flexibility. 5G and future 6G networks are enabling low-latency communication between massive robotic fleets operating in real time. And reshoring manufacturing back to domestic markets is becoming increasingly possible because scalable robotic labor reduces dependence on low-cost overseas workforces. As this trend accelerates, some of the industries most exposed include manufacturing, logistics, healthcare, warehousing, and agriculture. But despite the enormous opportunity, robotics also comes with major structural risks. One challenge is the high upfront capital investment required for robotic deployment, especially for smaller businesses. Another risk is safety and liability. Autonomous systems operating in human environments create complex legal and regulatory challenges. Interoperability also remains a major issue. Different robotic platforms often struggle to communicate within unified industrial systems. At the end of the day, the robot age is not simply about machines replacing workers. It is about transforming artificial intelligence into physical productivity infrastructure capable of operating at industrial scale. And as robotics, AI, sensors, and autonomous systems continue to converge, intelligent machines may become one of the defining infrastructures of the next global economic era. If you want to understand markets, you have to understand this system. Subscribe to NAVIXA for clear, structured market insights.